Good day. I'm going to teach you how to deal with trigonometry in the Cartesian plane. And before I start, just kindly like the video and don't forget to subscribe to receive more of this stuff. So in this particular question, they tell you that if 2 sine theta minus 1 is equal to 0 and theta is between 90 and 270, they can ask you to solve for maybe cos theta, right? Number 2, let's say tan theta times cos theta. And let's say number 3, they ask you to find sine 90 minus theta. So how do we solve this thing? We have to draw a diagram. But now the common mistake that a lot of people do is just to randomly draw a triangle. It doesn't work that way. The reason why we can't just randomly draw a triangle is because for different questions, there are actually different quadrants that the triangle can be in. So we need to figure out which quadrant is the right quadrant to draw the triangle. Sometimes it can be in the first, second, third, or fourth. So for us to be able to tell, we need to first solve this. We have to solve for sine theta and make sure that sine theta is the subject of the formula. So how do we solve for it? We have 2 sine theta minus 1 equals to 0. So we have to take 1 to the other side so that we can be left with 2 sine theta is equals to 1. Then for us to be left with sine theta, we have to divide both sides by 2. And then we're going to be left with sine theta is equals to a half. Then from there, we see that sine is positive. But the problem is sine is positive in the first quadrant and in the second quadrant. If you memorize this thing, all students take chocolate or COVID. So this means everything is positive in the first quadrant. This means everything. It means only sine is positive. Here it means only tan is positive, meaning that sine and cos is negative. There it means only cos is positive, meaning that sine and tan are negative, right? So I hope you understand this. Here, all trig ratios, sine, cos, and tan are positive. Here, only sine is positive, meaning that cos and tan is negative. There, only tan is positive, meaning that sine and cos are negative. There, only cos is positive, meaning that sine and tan are negative. So always cram this. So now when we look at this, we see that sine is positive. But now sine is not only positive in the second quadrant, it's also positive in the first quadrant. Because in the first quadrant, we said all are positive. So we're not yet sure which specific quadrant must we draw the triangle. We know that we have to draw it in the first quadrant or either in the first quadrant or in the second quadrant. But how do we know which one specifically is correct? Then we have to look at this information. This information says this angle is between 90 and 270. And 90 is over here, 270 is over there. So it's between 90 and 270. So it's anywhere between this. But this is 2 quadrants as well. But notice, sine is positive in the first and second quadrant, right? And yet this thing says from 90 to 270. It's saying we must draw it in either the second or third quadrant. But between the second and third quadrant, which one has sine as positive? It's the second quadrant. So it means this is where we must draw it. Right, because this is positive, it's positive in the first and second quadrant, and this information says we must draw it in either the third quadrant or the fourth quadrant. So the place that there's 2 ticks is the one that we should draw. So it's the second quadrant because it agrees with both informations. The information that says we must choose the one that is positive, and the one that we must choose is between 90 and 270. So the one that we should draw this at is in the second quadrant. So we always draw a vertical line connected to the x-axis, not the y-axis. So we cannot do this, right? Always connected to the x-axis, no matter where the triangle is. And we've got y-axis, x-axis. Now here we've got sine theta is equals to opposite of our hypotenuse, right? Our opposite is 1, our hypotenuse is 2. So it means our opposite is 1, our hypotenuse is 2. Now we have to solve for the adjacent side. And when we solve for it, we'll use Pythagoras theorem, which is r squared is equals to x squared plus y squared. But now be aware that this is not side work. You have to show them this work. There is 1 or 2 marks for this. So our r is 2. So 2 squared is equals to our x squared, which is not known, plus our 1 squared. And this is going to be 4 is equals to x squared plus 1. Take this to the other side. It means 4 minus 1 is equals to x squared. And then it means 3 is equals to x squared. So for us to get rid of the square, we have to square root both sides. So when we square root both sides, our answer is plus or minus 3. It's not just 3, it's plus, or it's not just root 3, it's plus or minus, because every time we square root something, there's a plus and minus. So this is another common mistake that a lot of students make. They usually put the positive side, and sometimes it's wrong. So according to this diagram, which one is correct? Must x be a positive or a negative? As we can see, this is the negative x-axis, so our correct answer is the negative version. So this is why some people miss marks, because they just square root and write the positive side, but it's not true. So here it's negative. So sometimes the positive one wins, sometimes the negative one wins. It depends on where this thing is drawn. So every time before we continue solving, before we answer this question, we always have to find the missing side. And even before finding the missing side, of course, we have to draw it. And we don't just draw a triangle. Remember that. We have to determine which quadrant is correct to draw the triangle. So let's answer the first question. So this is the second quadrant. So we'll illustrate from the 0 part, right? From where the angle is 0 up until it touches the hypotenuse. So even though the angle is outside, we pretend as though it's inside and we solve. But here's an advice. Every time we have this angle, always have this one, which is 90 minus theta. If this was beta, then this side will be 90 minus beta. If this was maybe 126, right? Or rather, they won't give you something like that. If it was maybe 45, then there you would put 90 minus 45. It will also be 45. If it was maybe something like 39, you would say 90 minus 39, which is going to be 51. So we always have to include this because of some types of questions that come out. So let's answer this question. So they say cos theta, right? So remember, we pretend as though it's inside. So cos is adjacent over hypotenuse. So our adjacent is going to be square root 3. So cos theta is equals to negative square root 3 over our hypotenuse, which is 2. So we answer the first one. So let's answer the next one. So tan theta times cos theta. So what is tan theta? Tan theta, we pretend as though it's inside, so it's opposite over adjacent, which means our opposite is 1, our adjacent is negative square root 3. And then now we're going to also have to substitute for this one. So we substitute for this and this at the same time. So we substitute for this one. So what is cos theta? Cos theta is adjacent over hypotenuse. So our adjacent is this stuff, our hypotenuse is 2. So our adjacent is that, our hypotenuse is 2. And then when we look at this, of course, you can type this in a calculator and get your answer. But without the calculator, whatever is the same but on different lines obviously cancels out. So our answer is going to be 1 times 1, which is just 1, 1 times 2, which is 2. So that's our answer. So our answer is half. So we answer the second one. And then let's answer the third one. So sine 90 minus theta. So a lot of students go, whoops, they don't have it. They don't know what to do with this. But the thing is, you will not be stuck if you have it in the diagram. That's why I always advise you to always put 90 minus whatever angle they had. So we have 90 minus. So if this, remember we pretended as though theta is inside. So if this is theta, this one will be 90 minus theta. So if that's for sine 90 minus theta, we're now referring to this angle, we're no more referring to that angle. So what is the sine of this angle? It's opposite over hypotenuse. Our opposite is whatever the angle is directly facing. So our opposite is square root 3 in this case. So it's square root 3 over 2. So a common mistake of a lot of students is to memorize that this side is adjacent and this side is opposite. It's not true. It depends on the angle. Whenever we have a triangle, we cannot memorize this as adjacent and this as opposite. It depends. So for instance, let's call this the alpha, let's call this beta. If I ask for sine alpha, then A is going to be our opposite, right? Opposite over hypotenuse. But then if I asked for sine beta, let's call this one C, just an example. Let's call it B, let's call this C. So if I ask for sine alpha will be our opposite, which is A, over our hypotenuse, which is C. But if I ask for sine beta will be B instead over C, because whatever is opposite is whatever the angle is directly facing. So it depends on the angle. We can never memorize a side as positive, or a side as opposite and a side as adjacent. It depends on the angle. To this angle, this side is opposite, but to this angle, this side is adjacent. So it depends. So I showed you how to answer the questions. Now let's just master the part of drawing of which quadrant is correct. So let me give you another example. Here is another example. So beta is between 180 and 360, and they gave you this stuff. So for us to determine the right quadrant to draw, we have to say, we have to solve. So we'll take 1 to the other side, and it will become 2 cos beta is equals to -1. We divide both sides by 2 so that we can be left with cos beta. So cos beta will be equals to -1/2. So we see that cos is negative. And then this information, so where is cos negative, by the way? Cos is negative on the second and on the third, because all students take chocolate, meaning that cos is positive here and here, so it will be negative on the other side. And then this thing says the angle must be between 180 and 360. So between 180 and 360, so it's this quadrant and this quadrant. So the quadrant that has 2 ticks is the quadrant where we must draw the triangle. So it means this is the correct quadrant. So when we draw it, of course, we'll have it like that and we'll connect. So our adjacent, so our hypotenuse is always positive. So now this tells us cos is adjacent of our hypotenuse. So our adjacent will be -1. Then we're going to have to solve for this. And when we solve for it, we'll end up having a plus or a minus square root 3. So which one is going to be correct? When we use Pythagoras theorem, it's going to be a minus because this side y is negative. So be careful of that. Here is another example. Let's say you are given this and you're told that theta is between 90 and 270. So how do we know the correct quadrant we must draw this thing at? We obviously have to solve. So when we take that to the other side, we'll be left with tan theta is equals to -1. And then when we divide both sides by 3, we'll be left with tan theta is equals to -1/3. So we see that tan is negative. So where is tan negative? All students take chocolate, so it means tan is positive here and here, meaning it will be negative here and here. And this thing says we must draw it. It says it's going to be between 90 and 270. So between 90 and 270, so it's this quadrant and this quadrant. So the one with 2 ticks is the right one, meaning that we must draw it in the second quadrant. So it's opposite over adjacent. So it means our opposite is -1. Our adjacent is this cannot be -1 because it's on the positive side of y, meaning that the negative in this case will end up belonging to the 3. Whenever overall you have a fraction as negative, it means that either one is negative. It can belong to any. And of course, we'll have to solve for the hypotenuse. So it's going to be square root 10 when we solve. Alright, so if you like this video, don't forget to subscribe so that you can receive more stuff. And if you've got more questions or you want me to explain something, comment on the section below and I will. If you want me to make a video, I will.